Okay, I will start on my presentation, but it is first author is Carter University's people, Sansom, and this presentation is coming from the my part as well as the Sansom's part. And today's first presenter, Dr. Abe, is also the co-author, and this is a collaboration project of the Australian and the Japan part. As you know, the Hayabusa 2 spacecraft was successfully re-entered onto the Australian desert at December 5th last year. Today, I will talk about this observation result. First of all, I remember my first re-entry observation led by Peter Enriquez at NASA DC-8 operation. At that time, so it was 2006, since Abe is also operated our instruments, and I was something like the helper of Dr. Abe at that time. After that, I realized the importance of the infrasound observation, and today's my talk is almost consists of the infrasound observation, but the other side, the other observation was also operated by many people. And as you know, the meteors or the meteorites enter to the Earth at the time. So hypervelocity meteorites can touch on the upper atmosphere and take shock waves, then to be propagated onto the ground as condition of the upper atmosphere. Condition like the velocity distribution on the upper atmosphere as well as wind condition. But in reality, the meteorite is not only the one source, but also the other side, the many geophysical events can produce the infrasound. So currently, my question is not only the meteorite, but also the many detection of the such kind of waves, as well as also the disaster mitigation. So the purpose of the infrasound observation is very widely spreaded. So disaster mitigation is also important, but the other was, so the aerospace engineering or geophysics, astrophysics is also important. Then the other side, the environmental study like the wind turbine noise effect is also important for our human health. In 2011, at the time, so as you remember, we affected huge disaster by the tsunami affection, as by the magnitude 9 huge disaster. At that time, the very important thing was the tsunami alert was not good for the scientific approach at that time. Then our importance for the infrasound observation is to be shifted to the disaster mitigation for our laboratory. So after that, we got some fund from the company, and we distributed currently 30 sensors on the seashore of the Pacific Ocean of Japan to measure the tsunami-induced infrasound. But the tsunami is not occurred so much so that we don't detect such waves. It means that we are safe. But it detects the volcanic eruption coming from the Kyushu Island to our region, as well as, of course, infrasound coming from the natural meteors. So please go to the Hayabusa re-entry session, and this is 10 years ago, Hayabusa 1 reentry. At the time, we deployed the sensors at the Woomera Desert area of Australia, the Shinsuke and I and the many members from Japan rushed into the Australian desert to observe the many instruments. But at the time, the sensor was limited for the infrasound, so only 5 sensors of infrasound we have to deploy these kind of areas and the operated Hayabusa 1 reentry observation. As you remember, maybe the Hayabusa 1 spacecraft cannot control by the maneuver, so that they operated, JAXA people operated as re-entry of the capsule as well as the non-controlled mother spacecraft followed by the SRC. So we have the magnificent event of the fireball by the explosion of the mother spacecraft at that time. So very, very bright fireball out there. At that time, just after a few minutes of the re-entry illumination, we have the seismic waves as well as the infrasound waves, as well as the coupling process we have at the time of the 10 years ago. And it was a very good observation project at that time, but we only have the 5 sensors for the infrasound. I remember the 2 years ago, safer days at Bratislava. We have Meteoroids 2019 international conference. And at that time, we communicated with Curtin University's people in Australia for the coming project of the Hayabusa 2 spacecraft re-entry to the Australian desert. They informed us that their contribution to the Hayabusa 2 project, because of they have the desert fiber network at their desert area, so that the conversation was very good, and we promised them that we will visit Australia 2020. But just after that, the COVID-19 situation was making worse, and we cannot visit Australia finally. But the importance of the international coffee break session is, I remembered, if we did not conversation with them, it is very difficult condition for us to make a plan B. So our plan B observation leading university was Curtin University, Australia, and JAXA. But our university, Kochi University of Technology, as well as the Nihon University, Abe-san, as well as the Ibaraki University, Nozawa-san, we cannot visit Australian desert at that time. So we operated the 4 observations, optics, spectroscopics, infrasound induced seismic, and the plasma induced UHF waves operated by the Ibaraki University instruments. This is a distribution map of the DFM, Desert Fireball Camera System, and this video observatory network in Australia, not established at the time of the Hayabusa 1 re-entry, but in 10 years, they distributed so much for coming days. So we try to distribute our infrasound sensor as well as their DFM network. And we distributed 21 data logger of our laboratory design as well as the company design ones for 7. So total 28 infrasound sensors to be deployed on the desert area. So this is the timeline of Hayabusa 2 re-entry for the TCM maneuver from the very far away from the trajectory to be the near of the Earth. At the time of the TCM4, we can target it to the Umera area. After that, the capsule slowed, and then the TCM5, this time the Hayabusa 2 mother spacecraft can move to the other observatory, to the minor planet. So this is an observation map of our instruments, as well as the previously distributed seismic, as well as DFN video network. Unfortunately, we cannot visit there, so that's every effort was driven by the Carter University team. So this is a photograph of the Cooper Perry site of the Hayabusa 2 reentry, taken by Carter University team. And the Cooper Perry site is here, so that the almost below of the trajectory. And after passing of the Cooper Perry skies, we have the observation for the 7 sites for the infrasound, as well as the seismic, as well as the spectroscopic observation. It is the summertime, so in the afternoon, they have 45 Celsius degrees, so it is a much difficult condition for the sensors. So it is preliminary results for our infrasound sensors, and it is one-sided result for the 4 arrayed sensors. So you can see the small time difference coming from the shock wave to the site, and such observation we have 7 sites observation, so that in total 28 data set obtained for this reentry. This image shows us the velocity or the displacement of the seismic station, but this time we only deployed 4 sites for the seismic station. And this is a challenging observation of the UHF observation, operated by Dr. Nozawa, Ibaraki University. And they operated automatic detection system of the UHF for the 2 sites, but unfortunately the system was not good for the working time for the reentry, so that we have no data, but it is very challenging, and we hope we will begin another project like the Osiris Rex in 2023. I'm not sure about it. And the other thing is spectroscopic. It is a part of the Dr. Abe, so that I don't know the exact situation of the reanalysis, but please ask him if you have interest. So the summary, international collaborative ground observation of shock waves of Hayabusa 2 reentry was successfully operated with JAXA collaboration. At that time, so we have 28 infrasound sensors there, and every sensor of infrasound operated by Carter University team due to COVID-19 situation, but it was very successful. And the trajectory estimation only by shockwave dataset has been tried, and the good analysis was almost dead, but we will make it on the paper, so maybe within a few months it can be opened. A coupling process between infrasound and seismic waves will be investigated with check sensors as well as infrasound sensors, and infrasound ground-based observation network can be applied to disaster mitigation preparation issue for many geophysical events we think, so that it could be operated in Japan or as well as the other countries in the worldwide. And we hope we will put our infrasound sensors at each Carter's DFN site in near future. Okay, thank you so much.